Start recording, and let's turn this on. Page 67. 67, page 67. So what I'd like you to do is I would like you to go to the bottom of page 67 and try your best to fill this in. Okay, and while you do that, page 67, you don't have to read it up here. You'll be able to see it in your book. I'll turn out the lights also so you can see a little bit better. Page 67. Try and fill that in to the best of your ability. You can work with your partner if you want to. And while you do that, I'm going to try and remember your names and take attendance. Okay? So, let's see. Today is January the 29th. Musin, not here. Taranya's here. Beta's here. Is she? Yes, she is. Young Wook's here. Xavier. Greta. Gustavo's here. Rico. Has Rico arrived? No. Okay. Owen is here. Bahar is here. Terren's here. Youngju's here. Charlotte. Brandon here? Brandon's away? Brandon's away. Mahan is here. Tanya's here. Did I get it right today? It's taken me a while, but there we go. Lassia's here. Alexandru? Not here yet. Okay. So, yeah. Change the class maybe? Yeah, I haven't updated my printout list yet. Let's see. Okay. Mohammed's here. Jofi's here. Chelsea's here. Ella, Matthew. Sumi is here. Noah. Eunice here. I saw Sambed. Ah, there you are. It's like I saw you come in. Since here. Celia's here and Caitlin is here. Okay, good stuff. So here on page 67, filling in the bottom of that page. And if you have finished doing that and you're just waiting for us, you can also try recording the length of these 3 pencils at the top of the page using those 3 rules. Okay, would anyone like to tell me one thing that we need when we write a measurement? Yes, Hanya. What are we measuring? Absolutely. What you are measuring. And then we would put in equals. All right, so that's number 1. Number 2, yes, Bahar. Sorry? Units. Very nice. Yes? 1 estimated digit, yes. If the thing you are measuring is exactly on a line, you must do what?
Add a 0 to it.
Add a 0 to it. Or sometimes 2 or 3 zeros, depending on what your smallest division is. Sometimes, just depends. Okay. Now the next one's kind of tricky because there's a lot of blank and not very much word. Did anyone have any success filling in those blanks? Sorry? Always measure, you're close, 1 more digit. Yeah. Then the smallest marking on the measuring device. And in any measurement, the final digit is always significant. No, sorry. Why did I write significant? It's because it's the last block of the day and I just tend to write things down. The final digit is always, it is significant, but more importantly, that final digit is what? Uncertain or estimated. It's not that it's not significant, but more importantly, it is the uncertain estimated digit. Okay, so make sure you use those rules to answer the top pits, and you can take a look at what I've written and you can decide if I've done a good job or a poor job. So if you've finished doing your own, you can look at mine and be like, oh, Ms. Spence, so bad. So don't copy down what I wrote because it is so bad. Yeah, that first one, if nothing else, I am missing the units. Terrible. Okay. What else is wrong with that first measurement? Pardon me?
Smallest marking
Oh, here, smallest marking. My smallest marking is 10 centimeters. Thank you for pointing that out. I forgot that in my other block. And if my smallest marking is 10 centimeters, then I can estimate to the 1 centimeter. So is my actual number good? Yes? No. Because if I'm estimating to the ones, I can't go past the ones. I can't have 2 uncertain digits. So I have to say, no, cannot do that. That is wrong. Okay? Because when I look at this, it could be 6 Maybe it's a 5, maybe it's a 7. I don't know. 6 seems like the best guess to me, but maybe it could be something else, right? Certainly can't say 6.5 or 6.0, okay? And is there anything else we're missing in this measurement? Yeah, we need our equal sign and we need something on the left of the equal sign. Yeah, so this is our length. So we're going to use the symbol L for length. And how do we show that it's the length of a pencil?
We write pencil.
We write pencil, subscript. Yep, pencil as a subscript. So just down at the bottom right. Okay, so the length of the pencil is 6 centimeters. What do we think of my second measurement? What is our smallest marking? Smallest marking is 1 centimeter. So my estimated digit is going to be tenths, 0.1. So do we like my measurement? No. I'm missing 2 things. What's one of the things I'm missing? The equal sign. Okay, so I need my length of pencil is, what's the other thing I'm missing? My estimated digit. So it could be 6.0 centimeters. Technically, I could have measured this as 0.59 or 6.1, or sorry, 5.9 or 6.1. Okay? And on our last one here, what is our smallest marking? This here would be 6.5, and then the next little marking would be 6.6. So our smallest marking is in the 0.1 position. Our estimated digit should be in the 0.01. Yeah, position.
Is it wrong if you say 1 millimeter before the smallest marking?
The only reason it's not wrong to say that, it just doesn't help you figure out how many decimal places you should have in your centimeter measurement.
Okay.
Does that make sense? Yeah. So in this case, 0.01. So we should have our marking as 6.00 or 6.01 or 5.99. Okay, so any of those would be okay. And of course, we would still need our length of pencil. All right, so that's good. We are now going to move on to the next page, 68. It's a bit of a long lesson today. I apologize for that. We'll get through it as quickly as we can. All right. We're talking about significant figures today. Some of you may have done this already in physics, so this may be a little bit boring for you. Should you want to go ahead and just work on something else, pick a section, read it, see if it makes sense to you. You can work ahead on anything at any time. No problem. Okay? Significant figures are all the meaningful numbers in a measurement. Okay? So what does a meaningful number mean? Well, if I wrote, this pencil is 6.7321489. I'm just making numbers up at this point, right? Like how could I possibly know those numbers with that ruler, right? So where do my meaningful numbers end? Which of those are actually meaningful and which ones should I just get rid of? After the 7, this is all nonsense. This is just made up nonsense. Yes, I can't know those because I'm already guessing at the 7. So that's what we mean by meaningful numbers. Another definition for significant figures is all the known digits plus our one estimated digit. In other words, all the certain digits plus one uncertain digit. So we're sure about the 6, we're uncertain on the 7. We have one certain digit, we have one uncertain digit. 1 plus 1 equals 2. So if you can make a correct measurement, counting the significant figures in that measurement is easy. You just count the digits. We got 1 digit, 2 digits, that's 2 significant figures. Okay, easy peasy. Just so you're aware, scientists, lazy people, often I won't write significant figures, I will write sig figs. Okay, easier to say, easier to write. I get even lazier and I will sometimes just write SF. Okay, because when I'm correcting papers, it's hard to write sig figs, so many times if that's what people are getting wrong. So just SF. I don't use this term a lot, but you will hear significant digits, okay, as well. Digits is just another way of saying figures. So, yes, we have 2 significant figures, one certain one and one uncertain one. And let's just take a look here. We could say that the length of our pencil was 6.7, and this is going to be an optional sort of notation here. And we have not yet talked about what the black diamond means. Black diamond means optional, bonus, okay? And I call it, just to have a name for it, I call it enriched. Okay, it's not really enriched in the same sense that if you had taken chemistry 11 enriched, you would have done 5 extra units, okay? Like on top of the 8 that we do. It's a crazy course, it's way too fast. Anyway, it's just like a little extra. So if you're interested in it, you can learn it. There will be credit for it on the test. But if you don't do it, it does not count against you. You can still get 100% without doing any of the enriched stuff. If you try it out and you get 50% on it, it doesn't make your grade go down. It just means you won't go up by maximum 3%. So if you do all the enriched stuff and you get 100% on it, I will add 3% to your grade. Okay? If you get 50% on the enriched stuff, I will add 1.5% to your grade. Yeah? So basically, I take whatever percentage you get, like if you got 75%, I'd go 0.75 times 3 and add that onto your grade. Okay? I only do it at the end of term because it's a lot of like number crunching. Okay? So don't ask me, what's my grade with the enriched stuff? I won't know. I'll know it at the end of term when I have to do it for report cards. Okay? But you can say, oh, I've tried some enriched stuff. I've gotten a few things right. My grade's going to be a little bit higher than it would otherwise be. 1% or 2 maybe. Okay? So, writing this, we call this the uncertainty. We are uncertain about that last digit, and writing plus or minus 0.1 is that little optional thing that you can do when you are making measurements. You can get that enriched credit for it if you want to. All right? What that means is that you could go up by 0.1 to 6.8, or you could go down by 0.1 to 6.6. All right? It just shows like how much uncertainty there is in that number. Huh?
How do you jump from 6.8 to 6.6?
So if I have 6.7,
oh, sorry.
Yeah, sorry, I'm starting from 6.7. Yeah. That wouldn't make any sense. You're correct. Yes. No. You have to pick a measurement. Okay, if you're making a measurement, you pick a measurement and then you're stuck with it. Okay? Well, because if you start changing, then how do you know whether you changed up or changed down? Are you going to go higher all the time? Are you going to go lower all the time? If you go higher all the time, your results are going to skew high. If you go low all the time, your results are going to skew low. If you try and go 50-50, how are you going to decide that? Are you going to flip a coin every time? Are you going to keep a little tally book? I went up this time. Oh, I must go down next time. Do you know what I mean? Like, you just got to pick a number and stick with it. And if you don't like my reason, you can just say, because Ms. Spence said so. Okay? Because that's how science is done. Yeah. Okay? All right. So here's a more precise ruler, and we'll talk about why it is more precise in just a moment. All right? Because, of course, on Friday, you have your quiz on accuracy and precision. Yes. Okay? So precision is more precise because it has smaller divisions on it. So what would you guess is your measurement for this one? Tell your partner.
You have to go one more than the last score.
Do we like 6.70? Could we have said 6.69? I mean, let's say we weren't as zoomed in. Could it be 6.69 maybe? Maybe. Could it have been 6.71? Maybe, you know, if we were zoomed out. Whoa, right? I'm like, my eyes aren't so good. It's so small. So it depends on your measuring tool, whether you're actually seeing it big or whether you're seeing it small or whatever, yes? So this could be any one of these. So what we would do is we could say this is 6.70 plus or minus 0.01. And then I would, of course, have to put the centimeters at the end. Okay? Now, why is this one more precise? Let's take a look at these three numbers here. And let's compare those with these three numbers here. 6.7, 6.6, 6.8. Yes?
When we're writing it, do we do 6.70 centimeters plus minus or just 6.70?
You can do it. There's a couple ways of doing it. It is okay to say 6.70 centimeters plus or minus 0.01 centimeters. You can do it with the centimeters just at the end. You can do it with the centimeters here and here. You cannot do it like that. Okay, because the 0.01 needs a centimeter as well. Okay, it's kind of like this is all one thing. So it's okay to put the centimeter at the end and it applies to everything. Yeah, good question. All right, so if we look at our two sets of numbers, which ones are closer together? These ones are closer together, yes? And if things are closer together, what do we say they are? They are more precise. These ones are further apart. They are less precise. So in general, the more significant figures in your measurement, the more precise your measurement will be. Yeah? And we're going to write that down at the bottom of the page. But I'll give people a minute to write this down if you want to. Do you want me to tell you guys a secret about water fountains? There's always a lineup at that water fountain over there, right? Always a lineup. There's a water fountain across from the stairwell. So if you don't know about that one, now it won't fill up your water bottle because it's not like the stick your water bottle under and it goes like this. You have to push the button and it goes like this. But I filled my water bottle up to here while there were still 6 people in line over there. So just a little trick for you. Also, it's not important anymore because now they have self-checkouts. But at Shoppers Drug Mart, they used to not have self-checkouts. You could go to the cosmetics counter and check out there, and there was never a lineup. Yeah. Good little tips. Of course, there's self-checkout now, so it doesn't matter. Anyway, I get a little bit, sort of ADHD at the end of the day. I'm like distracted by this and distracted by that, so I'm sorry. We'll try and keep it together here. All right, so in general, the more sig figs, the more precise a measurement will be. It's possible that you could have like a balance, that was broken. And every time you put something like an electronic balance, right? And maybe like just the software is off or something. You put something on it and it weighs 3.487. And the next time you put it on, it weighs 10.482. And the next time you put it on, it weighs 1.865. That means that your measuring tool is broken, okay? So the only time when it's not true that more sig figs is more precise is if your measuring tool is broken, okay? But most of the time, more sig figs, more precision. Okay, so this is just what we talked about, so we can skip over that. How about this little object here? What would you record its length as? Tell your partner what you think.
Or 0.
So I've heard a couple things. I've heard 0.79. I've also heard 0.8. But if you choose the 0.8, it has to be 0.80. Because what's our smallest markings? 0.1 centimeter. So we have to go to the 0.01. And of course, we would need the unit. Now this begs the question, are we sure about the digit 8? And the answer is yes, even though here it's a 7 and here it's an 8. It's only because we work in a decimal system, like we work in a base 10. So when you get to a 9, you click over to the next number. Do you know what I mean? Right? When you get to 79, the next one up is 80. But we're still only, the number that's actually different is really this one. We're only off by 0.01. We're not actually off by 0.1, even though the 0.1 number looks different. Does that make sense? Oh. Oh. Ah, yeah. Come on, behave. There we go. Okay, thank you. My problem with this pen is that the eraser button is here. And where do I hold the pen? Pretty much right there. It's really annoying. Anywho, are we sure about the 8? Yes. Ooh, I want a pen, not a highlighter. Yes. The 8 is a certain digit. And if you have a certain digit, is it significant? Yes, it is significant. Are we sure about that final 0? No. Is that a significant figure? Yes, significant.
You said 0.0 is
Hmm?
the 0.0 significant?
This 0 here, this one here, this one is significant.
Oh.
It's just not certain. But your sig figs are all the certain digits plus one uncertain digit. So that uncertain digit is significant. So all the certain ones plus one uncertain one. Yeah? Okay. I feel like there's a lot of stuff in here that we don't really need to go into, so we're just going to skip over this. Okay. Actually, no, we're not. These are actually different sized objects. The only reason I know that they are different sized objects is because when I made that object in Microsoft Word, I actually put in different widths. The numbers of the width are different. Can you see the difference? Maybe, right? Like maybe. But if I go like this, can you see the difference? You'd be like, not so much. And I'd be like, no. Okay, if you get in really, really close, you might be able to see the difference. Yes? That is error. That's what scientists mean when they say error. In science, an error is not a mistake. An error is the uncertainty in a measuring device, right? It's like your error, you have more error here than you do if I make it really big, right? And that's not because you're making a mistake. It's because you can't see it as well. The error is determined by your measuring device, okay? It's just in science, error is how far off are you from the original value, like from the actual value. So maybe later on, we're going to do a lab where you calculate the density of aluminum, okay? I'm going to give you some equipment, some aluminum. You're going to calculate its density using some lab techniques. And then you're going to compare it to what a scientist have gone out and they've done studies and like experiments with large volumes and things like that. And they've gotten it very, very precise. Maybe it's 2.70, blah, 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 7 digits. You're not going to get that close. Okay. You're going to have some error in your measurements because our balances only go to 2 decimal places, not 3 or 4 decimal places. You're going to have some error because our pieces of aluminum are small, not big. Bigger, you get less error. Okay? So scientific errors, if you're asked in a lab to talk about errors, you don't say, oh, I dropped my beaker and some of the product came out, so, oh, I don't have as much as I should. That's a mistake. That's not an error. Yeah? So when we're talking about errors, it is really the difference between the observed values and what is true in nature. So in other words, what you measure compared with the actual value. And that's what we're talking about when we're talking about error. So for example, one thing you might do in a lab is you might calculate the percent. Sorry. You might calculate the percent error. Okay, and how you do that is you take the, and don't worry about this line, I'll tell you what it means in a minute. You take the measured value, what you measure, and you subtract the actual value, you know, the accepted value that, you know, many scientists have repeated the experiment many times and they've taken the average of it and they've gotten a good result. So you go and you look, you can go in, you know, Wikipedia and find the density of aluminum to a high degree of certainty. Okay, and you can compare that with your value. You can find the difference between your measurements and the accepted measurements. And then to find the percent error, you divide by the actual value. And you multiply by 100 because it's a percent. And you find out, how far am I off? Am I 2% off? Am I 3% off? Am I 0.001% off? Okay. And if you're wondering, what the heck are these little lines here? Anyone know what those mean? Those are absolute value, okay? And absolute value just means make it positive, all right? Because usually when we're looking at percent error, we're not really caring whether it's too high or too low. We're just saying we're off by 6%, not whether it's high or low, okay? So this is absolute value. Make it positive. Okay. So the uncertainty in the number, that is the error. That plus or minus 1, plus or minus 0.1, that is the error. Now, I would like you guys to take a look at these three measurements. Oh. Yeah. Yeah, no problem. No problem. It's being recorded, so you're good. We're going to finish off this stuff and there will be a little bit of homework. I think the homework is 76, 77, 78. I think. Yes, 76, 77, 78. There we are. Okay. So I want you to look at, this is, of course, enriched stuff, but take a look at these measurements and see what you think about them. Which one of them makes the most sense? There's something wrong with all three of them, but which one makes the most sense? And you can talk with your partner about it. Discuss. So if you remember, this is A, fingers on your palm, thumb beside it, and then B, palm up, fingers up, thumb on your palm, and then C is just a C. Which of those do you think is the best? None of them are completely right, but which one is the best? Yeah, I got some C's, I got some A's, okay. The best one, like I said, none of them are really great, is C, because at least the uncertainty matches with this, because if we have 0.80, we can only be off by 0.01. Our answer could be 0.79, or it could be 0.81, right? What's actually wrong with C? What should we have in C? Yes? We need to have the centimeters at the end here. Okay, so that was the only thing that was wrong with that one. This one here, if we say 0.80 plus or minus 0.1, that would mean that our uncertain digit was the 8, right? Because that would be going up to 0.9 or down to 0.7. And then what is the point of that extra 0 there? Do you know what I mean? Yeah? And the same thing for this one. It's the same deal. Like, you can't change that first one there. Okay. So now we're going to ask ourselves, how many significant figures are in 0.80 centimeters? Remember, I said just count them, right? Make your measurement and then just count them. The only problem is we have this little 0 at the front. And that little 0 there just tells us that our number hasn't started yet. I don't have anything in the ones position. I could actually write this as 00.80, right? I don't have any 10s. I don't have any 1s. I just have 0.80. Sometimes you might even see somebody, it's unusual to write this way in science, but somebody might just write it as 0.80, right? Don't do that. It will make me unhappy. But that 0 just tells you that your number hasn't started. Okay? We call these zeros. These are zeros to the left. Of non-zero digits. And they are not significant. So if you have a 0 on the left, it's not significant, never significant. Zeros on the left are never significant. Okay? It just tells you that your number hasn't started yet. Yes? And I'm going to give you a little mnemonic device. Are you familiar with the term mnemonic? I will use this term a lot. Mnem is, I believe, from the Greek for memory. Okay? And so a mnemonic device, you don't pronounce the M is silent. A mnemonic device is one that helps your memory. Okay? And so the little device that's going to help your memory here is NYM. Okay, NIM. You're just going to remember NIM. The N is on the left. The M is on the right. And the Y is in the middle. Okay, so do you remember what I said about zeros on the left? Are they significant? No. Look, zeros on the left are? No, they are not significant. No, yes, maybe. Okay, no, yes, maybe, exactly. So we've just dealt with the ones on the left. No, they are never significant. Now, what the heck is in the middle? As long as you have a non-zero digit on the left, you can have as many zeros as you want in between. If you've got a non-zero digit on the right, those are numbers in the middle. Zeros in the middle. Are those ones significant? Yes. Okay, so the middle is yes. So you would say this number has 1, 2, 3, 4, 5, 6 significant figures. Just count them. Okay, so no on the left, yes in the middle. If we have zeros on the right, it is maybe. So we need to take a look at another example to see when it is significant and when it is not significant. Okay, so we're going to take a quick look at these little beakers here. And you are going to record what you think is the measurement for the beaker on the left and the beaker on the right. Yep, that's what we're doing. So you're going to flip the page and we're going to go there and you're going to write down what you think are those measurements.
I would say 61. The other one. But on the other one, just. That's how we know. Oh, got 60, then it's 61.
So can we agree that the first one is probably either 60 or 61 or 62, something like that? Yeah? Okay, it's one of those. What is our uncertain digit there? What position is it in? Are we unsure about the 6? It's in the 1's position. So we're sure about the 6, but we are unsure about the 0. And I'm going to focus on the 0 here because it's the zeros that are interesting, okay? So I'm going to pick 60. You could have written 61 though, and that would be fine, okay? But we're going to say, I'm going to look at the 60. Now, this one on the right, what would we say? Still 60. But this one here is a 60 where our uncertain digit is in the 1's. And this one here is a 60 where maybe it could be, I feel like, you know, if you just glanced at that, you'd be like, maybe it was 50. You know what I mean? Like if you hadn't seen the beaker on the left-hand side, you might just be like, yeah. So it could be 50. So who is the uncertain digit there? That's in our 10s. Okay, so there is our uncertain digit there. So these are actually different measurements. So if we focus in on this 60 and this 60, how are we going to tell them apart? Okay, so there's a few ways that you can say this one has 2 sig figs, whereas this one only has 1 sig fig. Okay, all right. And one way to do that is to put a decimal in the number. Okay, so what we can do is we can put a decimal in the number. And this is the maybe. This is where the maybe comes in. If there is a decimal, so if we say yes decimal, then the rule is that zeros on the right are significant. So yes decimal, yes significant. So if I write the number 60 with no decimal, if there's no decimal, not significant. So yes decimal, yes significant, no decimal, not significant. So here, no decimal, that means that 0 on the right is not significant, which means that this is your uncertain digit, that's 6. And that means that you have 1 sig fig. Just that 6, because that 6 is uncertain. 1 sig fig. I feel like it's too far away over there. I'm going to write it over here, 1 sig fig. But if we put a decimal, then yes, there's a decimal. So yes, that 0 on the right is significant. So now we have 2 sig figs, and our uncertain digit is that one. So zeros on the left are easy. No, never significant. Zeros in the middle are easy. Yes, always significant. Zeros on the right, you have to ask yourself, is there a decimal? Yes, decimal, yes, significant. No decimal, no significant. Option number 2, write your number in scientific notation. Now we're going to get around to scientific notation probably tomorrow, maybe Friday. It depends on, I don't know. Do you guys want to go back to particles for a little bit tomorrow? I feel like the mathy stuff is getting a little boring. Let's go back to particles tomorrow. We'll do scientific notation on Friday. Okay. So scientific notation, though, some of you are probably already familiar with it. If I have the number 60, that's the same as 6 times 10. Yes? 60 is 6 times 10. Now, 10 to the 1 is equal to just 10, right? Anything raised to the power of 1 is just itself. 3 to the 1 is 3. 100 to the 1 is 100, okay? Scientific notation, we always have to have an exponent on our 10. So 60 is equal to 6 times 10 to the 1. Now, I can either write it as 6 times 10 to the 1, but if I have 60 with a decimal place, I can write it as 6.0 times 10 to the 1. And what do I have in my number now? I can say yes, decimal. And that means that 0, yes, significant. And you notice how this 0, if it's not significant, it just goes away in scientific notation. I just don't write it. So you can see there's just 1 sig fig. Okay. So we have 1 sig fig and then we have 2 sig figs. Now this last one is a little weird. It's called an overbar and it's not what you think. Okay. This overbar is not, it does not stand for repeating. What the overbar means in this context is it means it is the last significant figure. It is the uncertain digit. The overbar indicates the uncertain digit. So if I write 60 with an overbar over that 0, that would be the same as writing 60 with a decimal place. And it would be the same as writing 6.0 times 10 to the 1. Okay, all of those have 2 sig figs, 2 sig figs, 2 sig figs. Now, if you really hate the overbar, just bear in mind, we don't actually use the overbar a lot. It would allow me to do something like, if I had a measurement like I had, I don't know, I don't want 100, I want a different number there. Let's say it's 200,000. Okay, say my number is 200,000, but I actually, say it was 200,000 kilograms. But I actually know that my uncertain digit is here. That 0 there. I could write it as 200,000 kilograms. And that says, how many sig figs do I have now? Right? So now we say I've got 3 sig figs. Okay? I could also rewrite that number as 2.00 times 10 to the, and I move my decimal place 1, 2, 3, 4, 5 places times 10 to the 5 kilograms. And if you don't know how that happened, don't worry. That's going to be our lesson, like maybe tomorrow late in the day or Friday. Okay? Are we good with that? Okay. So those are called trailing decimals. Do I care if you really know the name? Leading decimals, trailing decimals, or am I okay if you just call them zeros on the left, zeros on the right? I don't care what you call them. You just need to know if they are significant or not. Okay? So I'm never going to ask you, what do we call the zeros on the left? I just want you to know that zeros on the left are not significant. No. Zeros in the middle are, yes, significant. And zeros on the right are maybe significant. And you have to ask yourself, is there a decimal? Decimal, yes. Significant, yes. Decimal, no. Significant, no. All right. Bloody, bloody, blah. La, la, la. Let's take a look at the example 7 on page 72. Could we use a little 5-minute walk around? Yeah, everyone. Are we dying?
No.
Why don't you just go outside for a couple minutes? Go get some sunshine. Yes? Actually, let's all go. We're all going to go together. We're all going to go outside, just for 5 minutes, and then we're going to come back in. If you're going to be cold, bring your coat. What? We're just going outside for a minute or two, and then we're going to come back.
Close enough.
You don't have to walk in here. That's why it'll make it feel good. Come.
I learned them yes.
Okay, guys, you're too slow.
Oh, you messed it up. That was the oldest trick.
I don't understand it.
Damn, it looks so soft. You pencil fell for it.
I'm getting it there. Bro, we slept.
Yeah.
Bro, last semester I did that in physics. And I got a very fast, I got 50.33. I don't know where he's right. He's got it from the time.
Why did you reach in chemistry? That's why you reach because you're only other yeah. English, that's so hard. That's the least fun part. Yeah. Who's it? This is oh. I will see you right there. Yeah, sure. I thought yesterday. It was pretty good. She doesn't. No, you. That's crazy. Yeah, I got it. Like, I got it. Is it? Oh my god. She doesn't teach.
Alrighty. So we are on the bottom of page 72. So let's say we have this 100.0. We have zeros on the right. We have a decimal.
So we have 3 spaces on the.
So we have 1, 2, 3, 4 sig figs. Because the one is significant and the 3 zeros are significant. So we have 4 sig figs. If you have 100 with a decimal after it,
After the decimal.
well, we don't have a 0 after the decimal here. It's just,
for the
for the first one?
Yeah.
For number 1, yeah, there's 4 sig figs because we've got a 0 after the decimal as well. For the next one, how many sig figs? 3. 1, 2, 3. And how about
1.
this one? We've just got 1 because there's no decimal. Okay, so we got no decimal. Whoa, what did I just do? There we go. No decimal. No. These trailing zeros are not significant. So we just have 1 sig fig. So we have written the number 100 with 4 sig figs. We've written it with 3. We've written it with 1 sig fig. How could we write the number 100 with 2 sig figs? There's a couple ways we can do it. We could do 1.0 times 10 to the 2. Okay. The other way you could do it is to use the over bar. And that over bar tells us that this is our uncertain digit. Is good? Don't ever put an over bar over a number that is not 0. Over bars only go on zeros. Because you're never going to wonder, is that 1 significant? Is that 6 significant? Of course it is. If it's not a 0, it's always significant. Okay? So no overbars over top of non-zero digits. Is good? Okay. So this is just saying, okay, we're just blah, 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 blah. Let's, page 73. How many significant figures in 2000 with an overbar over that 0? There are 3 sig figs. Because that overbar tells us that we have our uncertain digit. No, the quiz on Friday is literally only section 1.2, accuracy and precision. Okay? What's it going to be out of? I don't know. Quizzes are out of whatever they're out of. So sometimes I'll have a quiz. I have like one quiz that's out of 54 because there's like literally 54 little things for me to mark. But it's no like it's not actually that hard. It's like counting protons, neutrons, and electrons in things. So that's out of 54. And you can have a quiz that's out of 5, but they're both worth the same. Okay? So every quiz is worth the same as every other quiz. And quizzes are worth 10% of your grade. So there you go. Okay? All right. Blah, blah, blah. I have so much blah, blah, blah. How many, we are now on the next page, example 10. I really need to streamline this. How many sig figs, this is on page 74. How many sig figs in the number 2.0 times 10 to the 3? 2. There is a decimal in the number, so those zeros on the right are significant. Sorry. It almost seems too obvious, but non-zero digits are always significant. So you would not put an overbar over the 3, okay? Because you're not wondering, is it significant? It is significant. So we have our leading zeros. Like I said, I don't care if you know what they're called, as long as you know that these are never, no. And you know that your trailing zeros, and like I said, I don't care if you know that they're called trailing zeros. What I care is that if you're decimal, yes, these are our maybes. If we have decimal, no. Then significant, no. Decimal, yes. Significant, yes. So how many sig figs in 3,400? In the one I'm going to color yellow right now. How many sig figs in that number?
2.
Decimal, no. Those zeros are not significant. So the only significant digits are 1, 2. We have 2 sig figs. Down here, decimal, yes, these are significant. So we have 1, 2, 3, 4, 5 sig figs. We're not going to fill in everything here. Captured zeros, those are the ones that are in between, and they are, captured zeros are always yes, significant. So no, yes, maybe. Okay? We're not going to do this, bloody, bloody, blah. So you can try the examples on page 75. You can try that one. Just do 76, 77, 78. Okay?
Thank you.
Have a wonderful evening. Go out and enjoy some more sunshine. Apparently the rain is coming, so you might as well do it now. Hi.
So for this one.
Yeah. Yeah. Because there's a non
On the right.
Yeah, does that make sense?
Everything in the middle.
So everything's sandwiched in between non-sandwiched is a significant.
Okay. And
Okay,
then
so
What do you want?
1, 2, 3, 4, 5, decimal 6. Right? Because it's on the right. And there's no. But if you have okay, so let's just do a couple things here. Okay. 1, 2, 3, 4, 5. Okay. No decimals? 1, 2, 3, 4, 5. 1. Because there's no decimal, none of these are significant.
on the right.
Maybe it's for right, because decimal yes.
Are you excited?
Decimal no. Significant no. Yeah. Well, we'll hit on it again tomorrow just to make sure you got it like solid. Yeah. Hi.
Did you say that we have a quiz with 54 questions?
Not with 54 questions. There is a quiz. My grade 9s write the same quiz, and they all survive it, and a lot of them get 54 out of 54.
But is it 54 questions?
It's not 54 questions. What I might have is I would have, let's say I have, okay? You're gonna have to fill this in. We'll have a little chart where you have the number of electrons, number of protons, number of neutrons, atomic number, and mass number.
Owen's stealing your time. Whoa.
Right? So based on this, you will look and you will say, on my periodic table, this is your free, so don't worry if you don't know it yet. On my periodic table, I have lead number 82, so I would fill in an 82 here. That lets me know that my atomic number is 82. My mass number is given here, 308. Yes, it is. My mass number is 208. That is my atomic mass, which is different than my mass, but we'll learn that in unit 3. Okay. That's that. So you would just go through and you would say, okay, and my number of protons is 82, and because this is neutral, my electrons are 82. Right? Do you see how if each one of these is worth a mark, it adds up pretty quick?
Yeah.
And if you draw a Bohr model, then right, and you're like, oh, I'm drawing a Bohr model. You're like, right? You get one for having the protons right, one for having the electrons right. You get one for having them in the right place. You get one if you have brackets, right? And your charge if it's an ion.
I remember that.
We're actually not going to spend a lot of time on that. Because they're, I mean, it's fun, but
It's not fun.
well, then you don't have to worry about it because we're not doing it this year.
We're
Excuse me now.
Thompson's model, because it's not practical. I mean, it's interesting to see the development, right? And I do it with my grade 9s for that reason, but it's not useful. You can't use a Thompson's model to do anything because it's wrong. No. Hi.
So I got a little bit confused. When the okay, so where was it? When the 0.1 started, so you know how we had like 0.7, like that would make sense because we know here. But could you please explain why, like, if we had 6.7, right? Why does the 0 come? I don't understand
Okay,
this.
because this could be 6.69 This could be 6.71, or it could be 6.70.
So if it's 6.7, how could it be 6.79?
This one could not be 6.79. This one could be 6.69,
Okay, so
right? So 6.69 would be right here. So I want a different color, so it looks like something different.
But I mean, I don't know. So how does the 9 come? Where does the 9 come from?
Well, if I was to put the end of my pencil here instead, right? If that was the end of my pencil, this would be 6.75. Yes?
Yeah.
Then if I put the end of my pencil here, 6.78. Yes? Or 6.79.
So 6.7, and then
And then an extra 9, because this gets 6.8. This is 6.8. This is 6.7. So anywhere in between is going to be 6.7 something.
and between these,
Mm-hmm.
how much do you have to count so you know exactly?
You don't know exactly. That's the whole point of that digit. That's the one you estimate.
So
if you are estimating, if you have this one here, which is, if we have 6.78 and we had one that was at 6.75, can we not have one at 6.69? Like maybe if it ended just like right here. Or sorry, 6.69 would end right there. Yeah? 6.6. And it's almost at the end, but not quite. 6.69. But it could also be, if you had something that was right at the end here, it could be 6.68, or it could be 6.70.
So if the pencil was over here,
Yeah.
that would be 7.1.
Something. And you pick your number. 7.15. And if it went to here, you could say 7.19, or you could say 7.20.
Oh, so it seems so it goes from like between these two, it
Uh-huh.
goes from 1 to 10 too?
Uh-huh. Yeah.
Oh, okay.
Yeah.
Oh,
Yeah.
okay. Okay.
I'm glad you asked. Good.
Because I knew
Yeah.
I got confused. I missed
Uh-huh.
that part. Also, one more question.
Mm-hmm.
I know the ones in the tens, but could you explain it one more time to me so I
Oh,
make sure
the
I'm-
positions?
Yeah, the
Okay.
positions.
So we have hundreds, tens, ones, tenths, hundredths, thousandths.
So from left to right, ones, tens, hundreds, right?
So 1, 10, 100.
Oh, this way?
Well, because if I give you a number like this, you're going to say that's a 1, right? That's 1. If I give you that number is,
Ones, tens?
because that's a 10, right? So this is the tens position. Now, if I go like this,
Ones, tens.
hundreds. So I have 100
Okay, so then 1, tens, hundreds in here?
here. Tenths.
Oh,
So like 1 over 10, 1 over 100, 1 over 1,000.
okay. So it goes 1, 2, 3, and then
Tenths.
why does it go like that? Shouldn't it be like one set? So if it goes like
So what's happening is with every place value, you're becoming, like, let's start here. This is 1 over 1,000. Okay.
Mhm.
This one is 10 times more than that one. This place here. This one is 10 times more than that one. This one is 10 times more than that one. This one is 10 times more than that one. That one's easy to see. 10 is 10 times more than 1.
so then
100 is 10 times more than 10. 1 is 10 times more than 0.1.
okay. Yeah, I gotta work on that.
Yeah?
Yeah.
Yeah.
Okay.
Cool.
And then the last question is that, so we said if decimal it's significant, and if it's not, then it's not. But if there is a decimal, then all these numbers over here are they will all be-
Everything is significant. Yeah.
Oh,
So
okay.
you're using it to figure out these zeros here. We know the 6 is significant, it's non-zero. We know the 7 is significant, it's non-zero. We have to think a little bit more about these zeros because they're on the right hand, or sorry, they're on the right hand side. We have to say, if there's a decimal, yes, they are significant. If there's no decimal, then they are not significant.
And how about, so if the decimal was here, right, between the two
Mhm,
zeros, will they still?
It'll
these
still be
zeros-
4 significant
Oh, okay.
figures.
As
Yeah,
long as
yeah,
there's a
yeah. As
decimal.
long as there's a decimal, it doesn't matter whether it's here or here or here. Yeah.
Oh,
Okay. Yeah.
Agnes question.
Yeah.
So from the three ways that we could find this, there's
Uh-huh.
this one, the overbar. How does it work?
It just tells you that's your estimated digit.
So if we put like 60 over, right? And
Yeah.
then what do we do? What's the next step?
That's it. You're done. You say, I have my 6 is certain, my 0 is uncertain.
Okay. And
Yeah.
then this one we do calculations.
We'll talk about more about
Oh, that one.
scientific notation later.
Okay.
Okay.
Thank you so much.
You're very welcome. Hi.
I don't really
Okay. So this one here, what you can see is that this is to the right. This one's way to the right of the target. Yes. This one's way to the bottom. So we have things that are to the right and to the bottom. And these are far right and far to the bottom. This one is top left, but it's not very much top left. It's only a little top left.
Yeah.
So if I had to average these three, I would draw my triangle. My average would be about there, which is not on the bullseye. The middle, yeah. So if you're looking at these and you're saying, where is my average? The average is in the middle.
So why is low?
So accuracy is low because you're not actually on the target,
So from 1 to 9.
right? So here would be accurate. This is more accurate than if my average were over here, but it's still not accurate.
1 to 9.
Okay.
I have average.
Yeah, for sure.
This graph.
Okay. So with this one, if I draw my shape.
It could be anything.
I don't know.
Only
Did you copy these from the video?
Yeah.
Okay. So I would say that the middle of my shape is probably, this one's a little tricky. I would tend to not worry. I would not give you one like this because it's hard to see where the middle is, right? I think the middle would probably be there, but I don't know. It's hard to say. But if you take these three and you look at the numbers, right? And you take your average, right? This is our average.
Yeah.
Okay. And if the actual distance was 500 feet, what we're going to do is we're going to compare our average to that 500 feet. Is it the same or is it really close? Is this really close to that?
Yeah. These two are.
Is 477 super close to 500? No. Okay. 498 would be very close. You could say that's pretty accurate. It's not perfect, but it's pretty accurate. This one is not accurate. Does that make sense? Yeah. And then if you look at your numbers here, is it precise? Well, this is way bigger than that. So no, it's not precise. These are far from each other. Right? So if these ones are close together, right? Because they're only like 5 maybe away from each other. This is like 3 below 500. This is 3 above 500. That's pretty close. So those are precise. They're close to each other. Okay. This one, you take the average and you say, is that close to 500. 501,
This is
close to 500?
Yeah.
Yes. So it is accurate. Okay. Yeah. You're welcome. Hi. Yeah. Okay.
Okay, so our question is, if there's a decimal, the whole number is all of them are significant, right?
Except if they're on the left. Okay, so if I have 0.000400,
Yeah.
the zeros on the left are not significant because zeros on the left are never significant.
Mhm.
So these are zeros to the left of my first non-zero digit.
Mm.
Okay, so I look for my first non-zero digit and I say everything in front of that doesn't count. Okay, but because there is a decimal, these ones are significant. Okay, so this would have 1, 2, 3 sig figs.
If it's 6.700, the
4 sig figs. Yeah.
So, and then over here, if there was like two more
Mm-hmm.
zeros over here, they're not significant.
No.
Because they come before.
Yeah. Any ones that come before, not significant, never significant.
Okay. So if there were two zeros before the 6, those zeros were not. Yeah. Yeah.
It's a weird notation. It is a weird notation.
I'm
You're
just
right.
making
But
this up.
you could put them there.
Yeah, I'm just making this up.
Yeah.
So these two zeros are significant. These two are not because they come before the decimal.
Also, even if they come after the decimal, if they're to the right of your first digit, they're not significant. It doesn't have to be, because you see, these two are not significant. They're after the decimal, but they're not significant because they are on the left of your first non-zero digit. So you look at your first non-zero digit and you say, are those zeros to the right? Not significant.
And what if you don't have a decimal after that? So what if
Then if you didn't have that, it would just be 1 sig fig.
Oh, okay.
Okay. So 3 sig figs, 1 sig fig.
Mm.
if it's 6,600.
Yeah. So if you had 6,700, get rid of that. It looked like a decimal. There's no decimal. So these are not significant. 2 sig figs.
Why do you?
Well, because it's 6,700. Otherwise, you just have 60. Otherwise, you just have 67. Do you know what I mean? And that's why people will sometimes tend to go, okay, I'm going to write that in scientific notation as 6.7 times 10 to the 3, just to get rid of those nasty zeros. On the other hand, this is a number where my brain automatically knows how much it is because I'm so familiar with it. Whereas this one, I have to think about it a little more. So, yeah.
Why is it 6.7? This can be.
Oh, these two numbers are the same because if I had 6.7 and I multiply it by 1,000, that's going to give me 6,700. Yeah, 6,700. Now, 1,000 is 10 times 10 times 10. Yeah, which is the same as 10 to the 3.
Yeah.
So 6.7 times 10 to the 3 is the same as 6.7 times 1,000, which is the same as 6,700.
I'm like, these can be like 67 by
You could, okay.
10.
So let's say we had 67 times 10 to the 2. That is a non-standard version. Okay, we don't do it. We always, when we're doing scientific notation, always have one number in front of the decimal and no more.
Oh, okay.
Okay, yeah, and we'll hit on that soon. Yeah,
Also,
yes.
why is this purely?
Okay, maybe it's not. It could be 0.79.
Oh.
Okay, you're right. You're right. It could be 0.79. See you tomorrow. That'd be fine. Yeah, absolutely fine. Okay, yeah.
What's the main point?
The main point of this is that your uncertain digit is that hundredths position. So if you wrote 8.8, it would not just be 0.8, it would be 0.80. Because your uncertain digit is that. It could be a 9, or you could tick over onto the 8. Yeah? Yeah.
So,
Okay. Okay. No, yes, maybe. Okay. I think I actually have something on it over here. Do I? No. Okay. So no, yes, maybe. So these zeros on the left. Okay. This is on the left. This is on the left. No, they are not significant. These zeros that are in between non-zero digits, yes, they are significant. And then these zeros that are on the right, so we go from left, middle, right, maybe they're significant. We have to ask ourselves, is there a decimal? If there is a decimal, yes, which there is here, then they are significant. Yes.
oh.
So we look at this and we say, these ones are not significant. No. All right. And so we start counting our number here. This is our first non-zero digit. And we go 1, 2, 3, 4, 5, 6. There is a decimal, so these 2 zeros, 7, 8 are significant. So there's 8 sig figs. Okay.
So this 6.
There's 8 sig figs. Yeah.
Again.
So we don't count these ones, right? Because our number hasn't started yet. You start at your first non-zero digit.
Our person has this
Yeah.
1.
Mm-hmm. Okay. Cool. Nice.
Thank you.
Okay. Anytime. If you forget by tomorrow, I'm happy to answer it again. Okay. I love your phone case. That is so cool. Love it.
I love the person.
Yeah, it's awesome.
Thank you. It's kind of matching with your
Oh yeah.